We have learned to calculate the probability of getting a certain number of defects in a random sample drawn from a lot. Today, we will discuss the implications of this, both from the perspective of the producer as well as the customer. When it comes to sampling plans, usually the military standard or the more recent ANSI standard is used as reference. There are three types of inspection: normal, relaxed, and tightened. We will look up the sample size and acceptance criteria recommended for AQL of 1.5% as per normal inspection plan. Using this sampling plan, we will calculate the probability that a batch as per AQL will be accepted. You would assume that should be very high, almost 100%. Consider another scenario. Assume the lot actually has a much higher defect rate, say 5%. In such a case, what is the probability that this lot might unintentionally get accepted as per this sampling plan? Ideally, that should be quite low, nearly zero, right? Well, not exactly. Using the formulas we have studied earlier, we find that the probability of acceptance of a lot as per AQL is 74%, not as high as we expected. But more worryingly, from the producer's point of view, that means that there is 100% minus 74%. That means 26% chance that it will get rejected. This is what is referred to as producer's risk. Ideally, this should be 10% or lower. On the other hand, for the lot with 5% defects, the probability of acceptance will be 36%, which is much higher than what we expected. This inability to reject a batch with higher defect rate is the consumer's risk. This should be in the range of 10 to 15%. This is easier to understand when we draw a graph. There are three variables: sample size N, acceptable number of defects in sample C, and the percent defects in the lot, P. Keeping N and C constant, we calculate the probability of acceptance for P varying from 0 to 10%. Lines corresponding to 90% and 15% probability of acceptance on the graph indicate the desired thresholds of producer and consumer's risk, respectively. The probabilities that we calculated earlier can be directly read off the graph. Okay, time now for today's assignment. The first is simple. What is the producer's risk if a random sample of 30 is taken from a lot as per AQL of 1%? Also calculate the consumer's risk if the lot has 7% defects instead. Up to 1 defective is acceptable as per the sampling plan. The second problem is, what should the AQL and RQL be for this sampling plan if we want to ensure that producer risk is no more than 10% and consumer risk doesn't exceed 20%? The first problem can be solved by applying the formula for cumulative distribution. For the second problem, while we can arrive at the solution by trial and error, it is better to approach it graphically. We draw the graph for N equals 30, C equals 1, and P varying from 0 to 10%. In doing so, we can read the producer and consumer risk for the first problem directly from the graph. Now, for the second problem, mark out the lines for 20% and 90%, which define the threshold for consumer's risk and producer's risk respectively. This leads us to an interesting insight. If we study the graph at a defect rate of 1.8%, the operating curve intersects the line of probability of acceptance of 90%. This means that for this sampling plan, as long as the defect rate in the incoming lot is within 1.8%, the producer's risk will be 10% or lower. So the desired AQL is 1.8%. At the other end, a defect rate of 9.6%, the probability of acceptance is 20%. So the consumer risk will be within 20% only if the defects in the incoming lot are 9.6% or higher. Therefore, the RQL is 9.6%. Interesting, but it just goes to show that working out a sampling plan means balancing risks. In the next video, we will learn to design single sample plans.